6.5, 6.6. Matrix product and inverse. These should be pretty easy sections, actually. We've been through the hard stuff. And the practice exam number 2 is out there for you. All right. So first thing we're going to do is, can the product A be calculated? So what we're going to do is we're going to talk about multiplying two matrices. So remember, we've made up this whole new thing. And you guys know what I mean by made up, right? Math is not real, right? Have we talked about that? It's an important thing to know as you take college level math class, right? Do we agree with that fact? Math is not real. If I said, think about it for a minute, right? If I said, hey, on the way to class today, I saw 3. There it was. I saw math. I saw 3. You would think, what do you mean you saw 3? I'm sorry. You saw 3 people? Or you saw 3 cars or something? I went, no. Not 3 people, 3 cars, 3 objects of any kind. I just saw 3. Right? You would say, what do you mean? You like saw the number 3 like spray painted on the wall? I mean, what do you mean? No, I didn't see the number 3 written anywhere. I didn't see 3 objects of any kind. I just saw 3. You would know I'm ready for the padded room, right? You can't see, taste, or touch math. Math's not real. It's made up. It's totally made up, isn't it? I'm really not supposed to let this secret out. Class over. I mean, what are we even doing here? Don't tell the dean I told you. Math's just all made up. What are we doing? No, it is. It's made up to describe things that are real, right? Math is made up to describe things that are real. If I saw 3 cars in a head-on collision in McKinley and Blackstone, and I came to class and said, hey guys, I saw 3 cars out there, head-on collision, McKinley and Blackstone, you know the concept of 3ness, even though it's made up. I know the concept of 3ness, and so we can talk about things involving 3ness in the real world, right? So that's kind of a hokey example. But how about sound? Let me give you one example of sound. Let me just try to fit math to the real world for you here for a second. Think about sounds. Anybody know how we measure sounds? Like how loud is my voice? Decibels. Yeah, what are decibels? Made up. They're totally made up. There's no, when sounds emit, they don't say, hi, I'm 82 decibels, right? They don't know how many decibels they are. They're just sound. They're just energy, right? We made up a system called decibels, we put numbers to sounds. Why? Because that would make life easier. For example, suppose you have a hearing problem and you're at work and you go to the doctor and the doctor tests you and says, all right, you're not supposed to be around sounds that are too loud at your office, at your work, because it'll damage your ear. So when you go back to work, tell your factory supervisor not to be around any machinery that's too loud. Well, what does too loud mean? How's the doctor going to communicate? How's he going to write a note to your manager at your factory that you shouldn't be around sounds that are too loud? How's he going to do that? What's the doctor going to do? Is he going to say, all right, you ready? Don't be around sounds that are any louder than this. And then you're going to try to remember this. You practice it all weekend. Then you go to work out Monday. You go to your manager and say, the doctor said I shouldn't be around sounds any louder than this. Are you sure it was this or was it this? Or which one was it? You know, that'd be a terrible system, right? Instead, we've measured the energy of sounds and made up a number system we put to it called decibels. And so the doctor can write a note and say nothing over 100 decibels. You can take that to work. They measure the loudness of the machines in terms of decibels, and it helps us deal with life. That's math. Math is made up to describe things that are real to make life more doable in that way. All right. So matrices are completely made up. You know, boxes of numbers. What's that? Made up, like the rest of math. They said, hey, that'll help us do some things. That's it. That's what all math is. They just realized it would help them do. You can type into Google and find out where they started. I think it was mixing beer or something, or some kind of chemicals. I can't remember. You can type into Google, find out. 1800s, 1700s, they first started using them. Boxes of numbers and called matrices, and it helps do certain things in the real world. So let's get down. So therefore, along with making up boxes of numbers called matrices, they made up the rules for them. How do you add them? How do you subtract them? How do you multiply them? How do you divide them? How do you do things with these boxes of numbers? And they made it up in ways that were convenient for what they're trying to do in the real world. Is it warm in here? A little bit warm in here? All right. I feel a little warm already. You guys aren't going to get sleepy now, right? It's nice and warm. Okay, good.
Get the light.
Oh, yeah, the light. That'll help. That'll make you real sleepy.
Oh.
There we go. All right. So let's take a look. So matrices. We already do we know the rules for adding them? That was the last section, huh? What are the rules? Like, how do you add 1, 2, 3, 4, and 5, 6, 7, 8? How do you add those two matrices? Well, what is the rule they made up for adding two matrices? Entry by entry, right? Upper left with upper left. 1 and 5 is 6. 2 and 6 is 8. 3 and 7 is 10. 4 and 8 is 12. Done, right? That's totally natural. That's what you would have made up too, huh? Me too. What's the case? What did they say about adding matrices? Like, what if this one is kind of long and thin like that?
You can't.
Yeah, they said don't do that, right? They said don't add matrices or subtract them that are different sizes. Only add or subtract matrices that are the same size. Why did they say don't? Because there was no real life use for it. They said, when are we ever going to use that? And they never saw a real life time where that would at all be helpful. So they just said, chuck it. It's not helpful. Okay, so now that's adding, subtracting. Now in this section, we're looking at multiplying. What are the rules for multiplying? Product means multiply, right? And product is multiply. What are the rules for multiplying? And then we'll get to dividing. What are the rules for multiplying two matrices? Well, matrix A. Let's say matrix A is well, they're telling me it's a 3 by 3. They're telling me this. They're not showing it to me, but they're telling me the size 3 by 3. And matrix B is a 3 by 1. Anybody know the rules already for multiplying matrices? Can you multiply those matrices? Now, if that was adding and subtracting, we would say no. You can't. They're not the same size, right? For adding and subtracting, they got to be the same size. Anybody know the rules for multiplying already? Do they have to be the same size?
No.
They don't. They don't. But they have to follow a certain other rule, which is fairly picky as well. And here's the rule. It's okay only if the inside numbers are equal, these two. You can only do it if the two inside numbers are equal, and they are in this case, huh? 3 and 3. So it's a weird rule. You can multiply different size matrices as long as the two inside numbers are exactly the same. What a weird, they made this up really different than you or I would have. Totally weird. Adding, subtracting is totally natural. Multiplying is totally weird. So the inside numbers have to be the same. And then, here's the other weird part, the size of the answer matrix is the two outside numbers. Which, in other words, I mean this and this. 3 by 1 in this case. So we'd say, yes, you can multiply them and the size of the answer matrix is 3 by 1. Because those are the two outside numbers, you see. So if the inside numbers are equal, you can do it, and the answer will be the size of the outside two numbers. Makes sense? I mean, it's weird. I know it's just like totally weird. Why in the world did they do it that way? We'll see some real-life applications. We'll see why. That's actually useful. Doesn't seem like it, huh? But that's actually the most useful thing. Okay, let's try another one. So number 2, they'll say, okay, matrix A is what, 4 by 3, and matrix B is what, 3 by 5. They're just giving us the size. They're not showing us the matrices. They're just telling us how big they are. Remember, the first number's down, second number's across. So matrix A is 4 down, 3 across. Matrix B is 3 down, 5 across. Anyway, can we multiply those two matrices? Yes. How do we know? The two inside numbers are equal, so we're like, green light, go for it. If those two inside numbers are different, it's red light. Can't do it, okay. Yes, we can do it, and what's the answer size? What's the size of the answer matrix? 4 by 5. It's just those two outside numbers. Done. That's all there is to it. Now, we haven't actually multiplied one yet. We're just doing the setup right now. We're just finding out what the size of the answer will be. We don't actually know how to find the numbers in that 4 by 5 answer matrix. We'll get to that in a minute. Well, we'll use our calculator. But it's going to be 4 by 5. That's how they determine the sizes. The inside numbers must match, then the answer matrix is the outside two numbers. Okay, so A is a 3 by 5 and B is a 6 by 3. All right, can we multiply those two? No, red light. Not equal, no go. You cannot multiply them. You just simply cannot multiply those two matrices. That's what we answered here. The product means multiply, right? The product AB does not exist. And then the second question, select the correct, the size of the product BA. Now what if we do BA? What if we switch the order, in other words? What if we put B first, what was B, a 6 by 3? And A second, 3 by 5. Could you do it in that order? Yes. Is that okay now? Weird, right? Hold on a second. Those two equal, it's okay, and the answer, what will be the size of the answer matrix? 6 by 5, the two outside numbers. And that's what I have there, 6 by 5. Are you telling me that you switch the order and you can suddenly do it? Yeah. Ain't that weird? That's nothing like what we're used to for multiplying. Normally we say you switch the order all day, it makes no difference with regular numbers, right? But when it comes to matrices, boxes of numbers, the order matters apparently. Did you just see that conclusion? Right? Think about normal numbers. If I go, 5 times 6, is that any different than 6 times 5? No way. It's 30 either way you do it. It makes no difference what order, right? But when it comes to matrices, boxes of numbers, clearly the order matters. AB is not even doable. But BA is totally doable in this case. So that's an important difference. This is a whole different world, isn't it? The world of matrix rules. If you go higher, if you get a math degree, you learn how to set up worlds like this, systems, math systems with things like this. So this is a whole nother math system, the matrix system. And there's different rules in this world than we're used to in the normal world, right? Normally we're used to, you can switch the order of multiplying. That's called commutative. Multiplying is commutative. But in this world, multiplying is not commutative. You cannot switch the order of matrices. Well, I mean, it'll change it. If you switch the order, it'll say change the answer. Or maybe not even be doable. Huh. Very different. Okay. So now we're going to actually multiply matrices. So first off, let's make sure it's even doable, even allowable. This first matrix, what's the size of this thing? You go down first and then across. So it's a 2 by 2. And what's the size of the second matrix? Down first and then across. 2 by 1. Do the inside numbers match? Yes, they do. So what will be the size of the answer matrix? Outside numbers? 2 by 1. Meaning the outside will be 2 across. Or no, 2 down. You always go down. I always forget you go down first. Down first. So 2 down. So the answer will have 2 numbers going down, won't it? 2 down, 1 across. We good? Now, let's actually find that answer. I would just do it in my calculator. Just put this in. Put this in as matrix A. You guys have your handy-dandy graphing calculators? Let's go to it. So put this in as matrix A. Put this in as matrix B. And then just go A times B. Let me do some steps for you so you got to hit second. Well, in fact, let me just get a fresh screen here so I can write it out for you. So we'll let this be matrix A and this be B. So you go second matrix. What do you do? There you go. Second matrix. Go over to edit. Hit enter. And then put in A. And then go second quit. Right, that's step 1. And then go back into second matrix. Go over to edit. And you got to go down to B this time. For the second time, hit enter. Put in B. Second quit. Right, and then third, you've got to go what? Second matrix, and then just hit enter to call forth A, and and then go times, and then go, well, here, I'll put the times down here, times, and then second matrix down to B, and enter, and then hit one more enter. That should do it for you. If you want to copy those down, there's the magic steps. A is a 2 by 2. How are we doing? So I'm gonna you guys have that copy down, okay?
The number 2 is second matrix, enter.
Second, number 2, second matrix, go over twice to edit and down to B.
Okay.
So you gotta go down to B for the second one. See how you're choosing that when we show it on the thing here? So when you do this, I'm about to do the second one now. So second matrix. See, I go over to edit and then down to B. Does everybody see that? That way I'm going to be editing matrix B. See what I did? I went second matrix. I've already got A put in. A is already in there. Go over to edit and down to B. So when I hit enter right now, I'm going to edit matrix B. I'm going to put in matrix B. Everybody tracking with me? So hit enter, and then you just put in matrix B. Matrix B is a 2 by 1. And it's, 4, negative 1? Like that? Is that good? Put in 4, negative 1. We good? It's working? Okay. So then we got matrix A, we got matrix B. We go quit. We go back to the main screen. And then we go second matrix. And now we're going to name them. We're going to use the name, which means call it forth like a magic spell or somewhere. Calling matrix A to the main screen. Calling matrix B to the main screen. So hit enter. So it just calls forth A. And then I'm just going to hit times. So over here, right here, times. Times. So that's A times. And then go back to second matrix again. Second matrix, second matrix. I'm going to say, hey, B, you come on out now. So go down to B. And hit enter. And I call forth matrix B. See how you put the matrices on the main screen? And then just hit enter one more time. Boom. It just multiplied matrix A times matrix B for me. And the answer is 25, negative 39. And just like we thought, it's a 2 by 1 answer matrix, isn't it? 2 down, 1 across. Questions on that? You guys able to do that on your calculators? Graphing calculators? Troubles with that? Is that working out? All right, let's try another one, and maybe I'll wander around and see if I can be of some help. Okay. So first off, is that even doable?
No.
What's the size? Those are different sizes, aren't they? What's the? Go ahead and write out the size of the first one. You better write those numbers out. Make sure. Don't just guess. Math is never about guessing. Well, you can guess if you check. It's about careful checking. Being sure. So what's the size of this first matrix? Down first, then across, right? So it's down first, then across. So the first matrix is a 2 by 3, isn't it? 2 down, 3 across. What's the second matrix?
3 by
3 by 2. 3 down, 2 across, isn't it? So can they be multiplied?
Yeah.
Yes, sir. The 2 inside numbers match. What's the answer matrix going to be? 2 by 2. It's weird, huh? It's smaller than either one of the originals. This is weird, isn't it? The way they made this multiplying thing up. We'll see the real life reason in a minute. It's actually very useful for things in the real world. All right, type them in. Put in matrix A, put in matrix B, crank it out. I'll do it too, and then I'll wander around and see if I can help. So I got the answer negative 62, 65, negative 85, and 5. Like that? You able to get that? Let me wander around for a minute. Help those that are having any trouble. Good. You okay with it? Yeah. All right. Good. Bring all on track. Okay. Okay with it? Good. Good. Anybody need help? You guys good? All's well? All right. All right. So that's that. Let's move on. What Disney thing is that?
Aladdin.
Is that Aladdin? Okay, you guys know. You guys spend more time doing Disney than me, or I just have bad memory. I know I've heard it. I just can't remember which one it is. So it's a whole new world.
Have you seen that meme?
There's a meme?
Yeah, it's Aladdin singing with Jasmine, I can show you the world, and it says, except the United States.
Except the United States? What is that? I don't get the joke. It's just... Because what?
The movie like takes place in the Middle East or whatever.
Oh, okay. Oh, so that, yeah, we can't go there, huh? Okay. Yeah. All right. So, anyway, so what? That is funny. So, what's the one in this world? In this world, we have a different kind of a one. Think about what one is. Think theoretically with me for a second. What is the role one plays in the real number world? You probably don't think so abstractly about this kind of stuff. One is what we call the identity element. It's like a mirror. It gives you whatever you multiply by it, right? Isn't that what one does? You times anything by one, you get back what you times, huh? It's like a mirror. You get your reflection back. We call things that play the role of one in systems of math, we call that the unity element in the system. So one is our unity element. Okay, so great. So what's the unity element in the matrix world? What matrix is there that you multiply by it, it'll be like a mirror, and it'll give you back what you started with? Well, it's this. It's actually ones down the diagonal and zeros everywhere else. We've seen that already with the RREF kind of thing, huh? It's kind of related, not as much as I have time to say for now. But basically, that's the one. That's the one. If you want to bother to type it all into your calculator, go ahead. I can tell you I know what the answer to that's going to be, and you know now too. If that's the big fancy one, guess what the answer is going to be? What we started with. Don't waste your time. That's what they're wanting you to discover, and I'm just telling you. That's what it'll be. You can type it all in and multiply it if you want to. That's a big fancy one. That matrix will give you back, will make you get back whatever you started with. It's like a mirror. It's the one in the matrix world. Ones down the diagonal, zeros everywhere else. You might think it would be like ones everywhere or something else, but it turns out that's what it is. Ones down the diagonal, zeros everywhere else will give you back what you started with.
Why is it negative 5 instead of 0?
Why is it negative 5 instead of 0?
Aren't you multiplying like negative 5 and 0?
No. Yeah, good question. Yeah, the rule, I haven't actually showed you how to do it, huh? We've just had the calculator do it automatically. It's not just entry by entry. In fact, we know it's not entry by entry because how would this one have done it? See, it's a special rule. In fact, I can tell you how it is. What it is, it's you start in this goes across and this goes down. It's really a complex by hand rule. Yeah, if you want to see the by hand, I can show it to you. It's really complex. Yeah, here maybe it'd be good to show one. I'll show you one by hand. Here's what. So you know ahead of time it's going to be a 2 by 2, right? Let's go back to. Let's do this one by hand. I'll show you how we could have done this one by hand. The way it works is to do it by hand. What's really happening is you start this guy and you go across the top row. Let me clean this up a little bit. You go across the top row and down the first column, and you multiply. Well, I can't do it. That was something. You multiply. Jump. So you go 3 times negative 6. 3. Oh man, I didn't make enough room here. Here, let me make it bigger. I'm going to squeeze it all in and not have room. So yeah, so what it's doing by hand on any of these is actually pretty complex. That's why I just use the calculator. So what it's really doing is 3 times negative 6. What am I doing? 3 times negative 6. And then it jumps. Negative 1, and this guy jumps. So negative 1 times negative, and this is all just one entry right now. And then it jumps again. It goes to the 7 and the negative 7. That's all just the upper left-hand corner. See, what is that? Negative 18 plus 5, two negatives, minus 49. That is negative 62. That's just the first entry. That's what the calculator did. It did all of that. It's actually a whole complex way they set up. Well, you might be thinking, why did they make it up like that? Well, we'll get there pretty soon. I'll show you the real life reason that's actually very useful to real life. And then, well, how do you do this next entry? Now you start in the bottom row and the left, because this is bottom left, you see. And you go again, you go with your left hand, you're always going across. With your right hand, you're always going down. Does that make sense? It's like that old riddle. Can you rub your belly and pat your head and vice versa? You know, you got your left hand's going like left and right, and your right hand's going up and down. That's how you always multiply matrices, by hand. In the olden days, when I was a student, we didn't have calculators that would do, not matrices. I had to do them all by hand. I did some terrible ones by hand. Anyway, the left one goes across, the right one goes down. So it's 4 times negative 6. We're reusing this row again, but now we're using it with the bottom. So it's bottom left. Okay, you go this times this, and then everybody jumps. This times this, plus 8 times minus 5. Then everybody jumps. This times this. Work all that out. What is that? Negative 24 minus 40 minus 21 minus 85. Then how do you do the upper right? Now we're going to go down the right, because we're in the right. Upper first, upper right. So now you go across the... Don't do that. I'm just... Hello. Scribbling everything. I'm going to go across this and down that for the upper right. 3 times 4. You always start... That'd be 3 times 4. Everybody jumps. Negative 1 times negative 4. Everybody jumps. I keep writing over that. What is that? 7? 7 times 7. So what is that? 12 plus 4 plus 49. 65. And finally, across the bottom right. So bottom right, it's going to be 4 times 4, 4 times 4. Everybody jumps. 8 times negative 4. Everybody jumps. 3 times 7. And that's 16 minus 32 plus 21. What's that? Minus 68. It's just 5. Yep. There it is. So you don't want to do it by hand, do you? You want to do it by calculator. That's what it's really doing. It's not just entry by entry. It's this whole left, up, down thing. Yeah?
If we do this by hand on the exam, would you give us extra points?
No.
Oh.
But it will be actually valuable to kind of know. You won't have to do the whole thing by hand. But because in a minute we're going to get to some real life applications. And it's important to know, like if you're doing this in the real world, say you're an admissions officer at a university, and you're trying to, we'll see some of these real life applications, trying to set up student fees, student names, and a whole matrix. You want to be able to tell the computer to do the matrix, but you need to know how the computer is going to start, so you know which way to put the matrix in. That was, I hope you paid attention to that. That wasn't just for nothing. Know that it starts left and goes right down. So your left hand's going across, your right hand's going down. Just know that much. And you'll know how to set, so when you put them into a computer, you know to tell the computer which one to put on the left, which one to put on the right, how to situate it. Because you know what the computer's going to do. Even though you don't want to do it all, you want the computer to do it, you still need to know what that thing is doing so you can direct it correctly. Does that make sense? We'll see the real life one. Do the sizes first, find out if it's possible or not. Then if it's possible, type them in. What's the size of the first one? 3 by 2. You go down first and across, right? What's the size of the second one? 3 by 2. So is it possible? Oh, is it 3 by 3? Oh, then yes. Yes, it's possible. All right, I don't want to do this one. I thought it was a no-go. Inverse by hand, but who cares? I could show you, but we just don't have time for everything. Just take your calculator. Put this into your calculator, 3, 2, 3, 6, and then go A inverse on your main screen. The inverse button is right above the matrix. Is it above the matrix? It's below the matrix. It is the matrix button. Yeah, so just put A inverse on your screen. Just type into A. So go ahead and put matrix A into the thing. Hit the button. I think you'll get 0.5 negative 0.25, negative 1.6666, 0.25. Is that what you get? I'm kind of guessing it. Here, I'm going to do it. Go to A. A is a 2 by 2. And did you guys find the inverse button? X to the minus 1. I had the wrong answer here, didn't I? Did you guys find the inverse button? It's X to the minus 1. It's on the left side.
So you type it in, and what do you do?
You put the A to the main screen. You got to call forth the A to the main screen. You know, so you enter matrix A, enter A, do second quit, and then go back to second matrix and choose A and enter. So you're calling forth A to the main screen, and then just hit X to the minus 1 and enter. And it'll just do the inverse. And I'm getting 0.5, negative 0.16666, negative 0.25, and 0.25. Is that what you're getting? We good there? Right, so you just have to enter matrix A and then quit. Then call it forth onto the main screen and hit X to the minus 1 enter. And it'll give you the inverse of matrix A. Now, they're going to ask you for fraction answers, I think. So I've got to help you turn this decibels answer into fractions. Do you remember how to do it? I said it once, and you never forget anything I say. Oh, I'm impressed. Some of you remember. Second, math, enter. Hit math, enter, and that'll change it to fractions. So you get a half, negative 1/6, negative 1/4, and 1/4. Math, enter, changes any answer to fractions. Math, enter. Did y'all get that? Okay. It's got to be right after you have the answer on your screen. Right after you have the decimal answer on your screen. Hit math, enter. And it'll change it to fractions. And they want fraction answers. Is that good? Is that working out? Questions I can answer? Math, enter. If your calculator ever says error singular matrix, that means the inverse doesn't exist. Some of them, the inverse doesn't exist. Did you get that one time?
Yeah, I just got it right now.
It'll say singular matrix. Is that what it says, singular?
Yes.
Yeah, that's kind of like, it's single. It's not married. I don't know if that helps you remember. There's not an inverse. There's not another one. It's just singular. I don't know why they use that word, but that works. Whatever. It just means there's not an inverse. Some of them there's not an inverse. So try that one. Type that one in. Just type that in your calculator. Do the inverse thing again. So second matrix. 3 by 3. I'm getting 2, 2 minus 1, 0 minus 1, 0, 3, 4 minus 2. Did you get that? For A inverse, the inverse matrix. So let me see if I can help. Let me know if I can help. Having any trouble? Good with that? Finding the inverse button and all that?
What was it called when you just switched the signs? The matrices.
Oh, that other day when we were just switching signs? That was just, what did they call that?
I thought that was
Yeah, that wasn't inverse. Well, it's additive inverse. Technically. This is multiplicative inverse. Yeah, if they say inverse, they mean this.
Alright.
Yeah, the other thing, they just said negative A, I think, didn't they, or something?
Yeah.
I can't remember how they put it. Yeah. Is that good? Are we all good there? All right, I'm going to move on. Grab me. Okay, so math is made up to describe things that are real. So here we go. So Vicky and Mo take classes at a community college and a local university. The number of credit hours taken and the cost per credit hour, tuition only, are shown below. So Vicky, at the community college, she's doing 9 units. And at Louisiana State University, or whatever it is, she's doing 9 units. Mo's doing 6 units at the community college and 3 at Louisiana State University. Here's the cost per credit hour at the community college. It's $79 an hour. At the university, it's $149.30 per hour. So, write a matrix A for the credit hours taken by each student, and matrix B, cost per credit hour. Choose the correct matrix. So, what? Write a matrix A for the credit hours taken by each student, and a matrix B for the cost per credit hour. Choose the correct matrix A below. Okay, so A is supposed to be credit hours. Well, that's 9963. There. That's a dumb question. It's just this, so boom. They're starting pretty simple. There's so many words, it can get lost in all those words. So they're just saying, hey, pick this one first off, make that into a matrix. Okay, there you go. That's obviously the matrix. Good so far? That's all they want. Let's go to the second part. Okay. So this is matrix A. This is matrix B. Right? I should maybe make it like a matrix. There we go. So there's A and B. And then right here, this is the answer to A times B. Matrix A multiplied by matrix B. So what's that? What do those numbers mean? I mean, in the real world, 2,054.70. What is that? So is this what, who's person, Vicky? Is this what Vicky paid and what Mo paid? Or is this top number the total money paid at the university and the bottom number the total money paid at the community college? Which one is that? Is it the people or the colleges? To know that, you got to know what the thing's doing by hand so you can know what the computer just did. See what I mean? See how a real-life user of matrices, programs that do this? Because there's this thought that, hey, we don't need to know math. Technology just handles it all now. Not true. You got to be a smart operator. Technology is just fast. It's not smart. It doesn't know what's what. You got to be the person who knows. Okay, I'm trying to figure out people's costs, or I'm trying to figure out colleges' costs. So I'll have the matrices go this way or go that way. Right? You got to be the smart operator. So which one are those two numbers? Are they the people or are they the cost? Well, let's go back and take a look. Let's look at what happened here. We took 9963 and we multiplied it by the 79 and the 149.30. Remember how it works. You go across and you go down, don't you? You go across and down. So we took 9 times this. Now what is that? That's the community college for Vicky. This is Mo. This is the university. That's the community college for Vicky times the community college cost. 79 per unit, right? And then I went here times there. Remember, you go across and you go down. Remember? This times this. Those are both Vicky calculations, aren't they? You with me? I went across here. Vicky, Vicky, Vicky. So this is Vicky. That's Vicky total. Those are people totals, not college totals. See how I know that? Because I went across. Remember, when you do a matrices, you start with the left one and you go across left. Well, how could you do it? So what if you really did want the total money? What if what you desired? Well, here, let's choose the right option. This is the tuition. Vicky pays. There it is. It's D. The tuition paid by Vicky and Mo, respectively. That's what it is. Right? This is Vicky and Mo. How do I know? Because the way matrices work, what the computer did was as you go, the calculators, you go across and you go down. So it did not, both these, boom, boom, it went like this, right? Both these are Vicky numbers. That was the first entry. Just find what the first entry is. Where did the first entry come from? From going across the Vicky row. So the first row is all Vicky, isn't it? So that means this first answer is all Vicky. So the other one must be all Mo. See how I know that? So it's Vicky and Mo. Now, what if you were the operator then and you wanted to figure, okay, I don't want Vicky and Mo, I don't want people. Now I really do want to know what was the total money spent at the community college what was the total money spent at the university? How would you do that?
Put B in front.
What's that?
Put B in front.
Yeah, put B in front. You'd have to put B in front. Good job. Put the 79, 149.30 in the front, right? And the other one in the back, but not quite. One more change. That won't quite work. Why not? Because that's a 2 by 1. This is a 2 by 2. That's a no-go. Inside numbers don't match. So what would you have to do with that matrix on the left? Write it sideways. 79 and 149.30. Now it's a 1 by 2. It's down 1, 2 across. Now I can go with the other one, huh? You'll go across this way, and you'll go down this way. And what's this down? This is all community college when you go down. Oh, no, that won't work at all. That won't work at all. Don't do that. That's a mess. Because that'll be 79 times 9. That's community college times community college. And then 149 times 6. 6 is community college, but 149 is the cost of the university. Now, that's garbage. Don't do that. That's garbage in, garbage out. You just told the computer to do something crazy. So I don't know how you would do it. I don't know. But we got the answer we needed. How about that? I'm not going to make up questions that they didn't make up that I can't answer anymore. These problems are bugging me now. All right. So, so this one. So basically, they want you just to type. See how they just went down here and type those across? And down here and type those across? That's all they're doing. Write the information in the first table as a 2 by 4. Yeah, so just make first table. Boom, 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 boom. That's all they're doing. They just copy down the information. That's all they did. And then in part B, they say, write the information in the second table. So now you take second table and just put them all in that. Does that make sense? Mm-hmm. And then they're probably going to have you multiply them or do something like that. I'm going to move on. All right, so I am going